This is 2007 FRQ Form A, B, C, number 6. So write the first four non-zero terms and the general term for the Taylor series for F. So it's e to the negative x squared. This is where you need to know the Taylor series for e to the x to make your life easier. If not, you're going to have to create this from scratch, which is going to be a lot of work, and you just might run out of time on the test. So it's 1 plus x squared over 2 factorial, x cubed over 3 factorial. How many terms? 4. Plus dot, dot, dot. The general term is x to the n over n factorial plus dot, dot, dot. And we have 5 things we can do to a series and a function. It's the composition. You can replace x with minus x squared. So the series for e to the minus x squared, you just replace all these with minus x squared to get your series. So pretty straightforward. Replace each of these. And we're going to have to do more work than just that because that's not going to be the proper form of a Taylor series. So we'll have to deal with that. Okay, so Taylor series needs to be x to a power. It can't be x to a power. That's not bueno. So we need to rewrite this. And it's just a matter of simplifying. So the even power makes this plus. That's why I have a plus there. And x squared squared is x to the 4th. So simply that. And then the next one, this is an odd power, so we're going to get a negative. And it's going to be x to the 6th. And then it's negative 1 to the n times x to the 2n over n factorial plus dot, dot, dot. Now, let's take a look at a couple of things here and make sure everything is looking okay. What happened? So the confusing part is this. What do you do with that? Because n could be even or odd. If n is odd, you're going to get a negative. N is even, you get a positive. So you can't just distribute it there, because what this really looks like, it's negative 1 times x squared to the n, and the rule is each one of these has to be brought to the n power. So that's why we ended up with 2 things to the n power. That's what's going on there. So that's the answer to part A. Part B, use your answer to find the limit, that limit. So we're going to have to do some work here. So 1 minus x squared minus, I need to put my Taylor series there that I just found. So it's going to be 1 minus x squared plus x to the 4th, 2 factorial, minus x to the 6th, 3 factorial, plus dot, dot, dot. And I have this. And that is all over x to the 4th. Now, let me simplify some stuff. So you have 1 minus 1. Those are going to cancel, so we can cancel those out. And then you have minus x squared, minus and minus become a plus x squared. Those will actually cancel out. So now we have this equals, and divide each, so x to the 4th divided by x to the 4th is going to be 1. So we're going to get 1 over 2 minus x squared over 3 factorial plus dot, dot, dot plus negative 1, negative 1 n x to the 2n minus 4, because you're dividing by x to the 4th. So when you divide, you subtract that from there. That's how we end up with that. Plus dot, dot, dot. I forgot my plus dot, dot, dot. So clearly, as x approaches 0, everything else is approaching 0 because you have x's in it. 0 times anything is 0. So this limit ends up just being 1/2, because that's the only one without an x. So that's the answer to part B. Let's jump to part C. We want the integral of the function, the Taylor series we just found. So I'm going to copy and paste it from up here because I am lazy. And we're going to have to do more work than just that too, just to let you know. So copy, paste, bam. But here's where we're going to get ourselves in trouble if we're not careful. It's dt and t. We got to replace all our x's with t's and make this dt. So all these x's, I'm going to turn into a t. If you don't do that on your test, Yoshida's not going to be happy. You're not going to be happy because he's going to take a point away. Now we have to integrate each term, term by term. So that's what we're going to do next. Oh, and 0 to x. Mucho sorry there. So the antiderivative of -1 is -1t. This could be t cubed over 3 factorial. You add 1 to the exponent, t the 5th over 2 factorial times 5. And you add 1 to that, it's going to be 7, 3 factorial times 7, dot, dot, dot. -1n. T to the, you add 1 to the exponents, t and 2n plus 1, n factorial, 2n plus 1, plus dot, dot, dot. And that's going to go from 0 to x. Now the next step, you're going to put x in for all the t's. Then you put 0 in for all the t's and subtract. But clearly when we put 0 in, you're going to get 0. So basically, you're just going to replace the t's with x's at this time. -1x minus x cubed over 3 factorial. X to the 5th. I'll just put 10 minus x to the 7th. 42, dot, dot, dot. Yeah. X to the 2n plus 1. N factorial. 2n plus 1, dot, dot, dot. Done, done, done. How many terms it asked for? Oh, it only wanted the first 4. I didn't need my general term. Oh, poopers. Oh, well. Oh, my, Yoshida. My. No? Am I mying? Did I do the right function? Let me double check. Did I do the right function? Why is that minus in front? I'm so confused. Oh, okay, I gotta back up. When I copied, I picked up that piece, part of the equal sign, so there shouldn't have been a minus there. That was throwing me off. So I think we're looking good now, and we only needed the first 4 terms, so we're mucho bueno. I didn't need this general term out here. Ooh, didn't mean to do that. Didn't need that. That's just extra unneeded things. So we did that, and it says use the first 2 terms to estimate the integral from 0 to 1/2. So the integral from 0 to 1/2 of our function is about equal to 1/2 minus 1/2 cubed over 3 factorial. Done. Don't simplify. All I did is replace these x's with a half. There is my answer. And I will stop there, and we will move on. Let's see. Let me back up. I think we're good. I'm a little confused, but I think we're okay here. T cubed. Oh, I see the... okay, I'm totally confused. I'm like, what's going on? This was squared. Add 1 becomes 3. Divide by 3, not 3 factorial. I was wondering where that factorial came from. Okay, that makes more sense. Much more sense. There's my answer. Now we're good. Now we're off to part D. Explain why the estimate found in part C differs from the actual integral by less. So we're trying to find the error, and we're going to notice about this series. This series, tis alternating, right? It's an alternating series, and the terms are decreasing. If you look, they are decreasing. And if you want to double check, you take the derivative, make sure that's negative. Okay, that's how you know it's decreasing. But I'm going to say this is an alternating series. That's a horrible series. Now, when you do this on the test, if you don't say these things, you're going to lose a point. The reason you're allowed to use the next term for the error, maximum error, is because it's alternating series whose terms decrease in magnitude to 0. Therefore, the error, or absolute error, is less than or equal to the next term. We only use the first two, so it's going to be the third term. It'll be that. Absolute value, x is 1/2, so it's 1/2 to the 5th over 10, which hopefully is less than 1 over 200, and we're going to be done. What's 2 to the 5th power? 4, 8, 16, 32. So it's 1 over 320, which is going to be smaller. So cha-ching, we are finished. Bam. And that is it.